Hello there, and welcome to Sleepy Cosmic Podcast, where we wander beneath velvet skies, following ancient light on its unhurried path through time. Tonight, somewhere far beyond our windows, Mars turns slowly in silence, bathed in a soft hue of dust and twilight. And further still, beyond our familiar planetary loops, something stranger drifts inward. 3 Atlas, a visitor from the interstellar dark. Not the first, not the loudest, but perhaps the most poetic in timing. If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe. No pressure at all. And if you're listening from somewhere quiet tonight, maybe beside a window or under covers, feel free to share where you're tuning in from and what time it is. Now, dim the lights, maybe turn on a fan for a soft background hum, and let's ease into tonight's journey together. Somewhere between the slow breath of stars and the hush of planetary dust, we find ourselves drifting with a question. What does 3i Atlas want with Mars? Of course, the object has no will, not in the way we usually mean, but the paths things take in space as in life can feel strangely pointed, as if shaped not just by gravity and chance, but by something more poetic. A gentle pattern we haven't quite seen in full, 3i Atlas was first observed in 2019, slipping into our solar system with a long soft arc, its speed and angle marking it unmistakably as an interstellar object. Its full name, C2019U3 Atlas, includes the 3i to note its distinction, only the third object ever identified as visiting from beyond our sun's domain. Before Atlas came 2i Borisov, a proper comet with a glowing tail that felt familiar even in its foreignness, and before that, Oumuamua, long and strange, speeding away without a trace of gas or dust, leaving behind more questions than light. But Atlas has a different rhythm. It's quieter, fainter, less discussed, even among those who watch the skies for such guests. Yet it too has wandered in from the cold, and somehow, as calculations traced its orbit, astronomers noticed something quietly poetic. Atlas had passed near the orbit of Mars, not close enough to spark headlines or worry, but close enough to make one wonder. What if the red planet was more than a waypoint? What if there was meaning in the nearness? We might picture Atlas as a drifting speck, its icy surface catching starlight that has travelled for eons, light older than any mountain on Earth, older even than our moon. Perhaps you can imagine it now, a solitary traveller tumbling through space, its path shrouded in unknown galaxies and dim regions of interstellar dust. We can't trace its origin precisely, only that it comes from a direction where no star claims it as kin. Mars, meanwhile, has always stirred our curiosity. Dry, red, hushed. Its surface is scored by valleys and whispers of water long gone. Its atmosphere is thin, offering no shelter from radiation or cold. Yet even from afar it feels familiar, like a neighbour who doesn't speak, but always stands in the yard just close enough to see. The idea that an interstellar object might careen into our system is not new, but the idea that such an object might have passed quietly by Mars, this dry watching planet, adds something more liminal to the thought. Could such a visitor have touched Mars? Could it have glanced off its atmosphere or even fallen, burning gently in the air like a sigh, leaving behind no crater, just questions? Astrophysicists remind us that 3i Atlas is probably a fragment, something long ago chipped or flung from a distant solar system, maybe even from the collapse of a distant star. There's no conscious aim, no destination in its mindless path. But there is trajectory, there is shape, and as it passed by Mars, not close enough to crash but near enough to mark in charts, a soft thought settled into the minds of skywatchers. Mars is a planet of memory. Its canyons and polar caps carry tales of ancient rivers and lost climates. The idea that it might receive, however briefly, a whisper from the far dark beyond, that idea is not science fiction. It's just science with a poetic edge, And so, tonight, we wonder aloud. What does 3i Atlas want with Mars? Not as a vessel with intent, but as a moment in a dance so slow we can barely see its steps. Perhaps it passed close simply because of gravity's subtle pull, because motion must bend to mass and time. Or perhaps, like dust on the breeze, it drifted through space's silence towards something that feels, at least to us, like significance. In the sections to come, we'll drift deeper, into the stories of other wanderers, into the physics of entry and atmosphere, into the thin veil of Mars's skies, and the quiet turbulence of its dust storms. We'll walk alongside old light and follow gentle curves through Lagrange points and gravitational arcs. But for now, we stay with this image, an object from the darkness between stars, passing a quiet red world that's watched the skies far longer than we have. We remember the first one, don't we? Oumuamua, the first known messenger from beyond. When it appeared in 2017, it wasn't just a curiosity, it was a whisper that the space between stars is not empty, that once in a great while something drifts close enough for us to notice. Oumuamua moved fast, too fast to be native to our solar system. It had no bright tail, no plume of escaping gas like a typical comet, just a tumbling, elongated form, reflecting sunlight in irregular pulses as it spun, like a shard of mirror drifting through a slow ocean. Astronomers only had days to track it before it faded from reach. It came and went like a breath, leaving behind open questions and soft speculation. Was it a fragment from a broken planet? A sliver from a shattered moon? Could it have been, as some gently wondered, an artificial object? Perhaps a derelict probe from another star? Most scientists lean away from such speculation, not because it's impossible, but because simpler explanations usually suffice. Still, Oumuamua marked the beginning of a new era. It reminded us that interstellar objects don't just belong to science fiction, they belong to the observable sky. They come, they pass, and if we're watching closely, we might just catch the glint of one. Then came 2i Borisov. Where Oumuamua was silent and strange, Borisov was comfortingly familiar. A classic comet, hailing from somewhere beyond, trailing vapour and dust as it swept by the sun. Unlike Oumuamua, Borisov was observed for months. It gave us time to track, to measure, to wonder. Its tail fanned out like a sigh of frozen breath, illuminated by the sun it would soon leave behind forever. And now, 3i Atlas, fainter, quieter. Its name comes from the Atlas survey that first noticed it. The 3i confirms its membership in the small but growing family of known interstellar travellers. Compared to Borisov and Oumuamua, Atlas made less of a stir. It's dimmer, more easily lost in the clutter of cosmic observation. But that very quietness makes it no less fascinating. What little we do know suggests it followed a high-velocity path, swinging into our system on a hyperbolic orbit, meaning it's not bound to the sun. It came from elsewhere and will return to elsewhere, a silent parabola through the garden of planets. And yet, when we trace that path, when we chart its ghost-like passage across the solar system, we find that it drifted close, tantalizingly close to Mars. Not a collision course, no, but an approach. A near miss in celestial terms, a soft intersection of trajectories in a system where space is so vast that close might mean millions of kilometres. Still, it makes us wonder. Because we've always imagined Mars as a place that notices things, a world that holds echoes. From canals once drawn by hopeful astronomers to the ancient riverbeds etched across its surface, Mars is a planet steeped in implied story. It's a planet that invites projection, a screen onto which we cast our myths, our science, and, at times, our dreams. So when a fragment like Atlas passes nearby, we can't help but assign some poetic meaning. Even if it's only in our minds, we picture the red planet turning slowly beneath a pale sun, its air thin, its surface cracked and ancient. In that sky, perhaps for just a moment, Atlas shimmered, reflected a brief arc of starlight, then was gone. No observer on Mars would have seen it, of course. The skies are empty there, the rovers are blind passing comets. But still, we imagine. There's another layer too, a more curious one. Because while Atlas passed near Mars, its orbital path wasn't chaotic. It was stable, traceable, calculable. It didn't dart erratically or spiral unpredictably. Some researchers noted its trajectory with interest. A quiet path? Yes, but not random. And that too makes us tilt our heads. Because the idea of non-random visitors, of fragments shaped by time, but perhaps also by ancient forces we don't yet understand, isn't entirely outside the realm of thought. After all, gravity is a patient sculptor. Over billions of years, it nudges dust into planets, planets into systems, and systems into grand rotations that span the breadth of the galaxy. So maybe Atlas was nudged long ago in a direction that led here. Not by will, not by plan, but by the slow stitching of celestial mechanics. Perhaps it drifted past long-dead stars through clouds of hydrogen, between knots of the cosmic web. Perhaps it has circled the galaxy more than once before finally brushing near this quiet corner where Mars turns in the dark. It's humbling, isn't it? To think how much motion occurs in the background of our still nights. And maybe that's what interstellar objects teach us best. That space is not still. That our solar system is not alone. That fragments fall, pass, whisper and fade, carrying with them a kind of message. Not in language, but in presence. A message that says the universe breathes, and sometimes it exhales visitors. Mars has always drawn the gaze, not just of astronomers, but of storytellers, thinkers, and quiet wanderers who look up at night and wonder what might be there. Among all the planets, it is the one we most often imagine as a mirror, not of Earth's present, but of its possible past or distant future, a world touched by wind, carved by time, and perhaps, long ago, by water. When we ask what 3i Atlas might want with Mars, we're not truly suggesting intention. But we're pointing to a feeling, one that many share when they look at the red world, that something about Mars invites connection. It's not just that it's nearby, in cosmic terms. Not just that it's reachable, it's that Mars sits at a threshold, too barren for comfort, too alive for dismissal. It teases us with signs of former rivers and frozen lakes, with whispers of methane in its thin air, and a landscape that seems to speak if only we could learn the language. For an interstellar object, Mars is a natural waypoint, the fourth planet from the Sun, orbiting beyond Earth in a colder, more ancient silence. Its thin atmosphere and desert plains make it a poor host for life as we know it, but a perfect canvas for imagination and curiosity. Perhaps that's why 3i Atlas catching even a glancing path near Mars feels meaningful. We imagine Atlas as small, a fragment, a frozen breath from another star, maybe no larger than a city block, maybe far smaller, tumbling, icy, carrying the chemical fingerprints of its unknown home, and yet, even in its obscurity, it intersects, however distantly, with this familiar rusty world. Mars, after all, has no magnetic field to shield it, no thick air to protect its surface. But what it does have is presence, a kind of enduring stillness. It has watched the solar wind for billions of years. It has listened, quietly, to everything that has passed. Some might say that if 3i Atlas had come just a little closer, it could have been pulled in, perhaps to skip across the high atmosphere, or even to burn away in a soft arc of light. But perhaps it wasn't meant to touch. Perhaps the nearness was the point. Like two ships passing in a vast ocean, their wakes never crossing, but their paths shaped by the same invisible currents. And this brings us to the geometry of orbits. You see, space may seem empty, but it has structure. Paths are not arbitrary. objects that fall into the solar system from beyond follow long arcing spirals, tugged by gravity in complex ways. When 3i Atlas entered our system, it would have been drawn slightly, not only by the Sun, but by the planets too. Jupiter, with its massive pull, often deflects comets or flings them outward. Mars, smaller, quieter, does its own part in this gravitational dance. So it's possible, maybe even likely, that Atlas's path near Mars was determined not by design, but by the unseen hands of ancient physics. And yet, that doesn't make it any less remarkable. Because in a system where distances are so vast and speed so immense, even a near approach is notable. It suggests that for a brief time, Atlas and Mars were neighbours, sharing the same patch of space if only for days or hours, and that closeness gives rise to soft questions. Could a fragment like Atlas leave anything behind? Dust? Molecules? A whisper of its origin caught in Mars's thin air? It's not impossible. Objects that pass through planetary systems can exchange material, tiny microscopic grains that float down like cosmic pollen. This is the idea behind panspermia, that life, or the building blocks of life, might drift between worlds on the backs of rocks and ice. While mainstream science doesn't assume this as fact, it's not dismissed either. In the hush of scientific circles, some wonder, could life have spread this way across the stars? Even if 3i Atlas holds no such potential, the thought lingers. Because Mars, more than any other world, seems poised on that edge. It's dry, yes, cold, but it's not sterile, not completely. We found organics in its soil. We found hints of saltwater brine beneath its surface. So when a visitor like Atlas passes near, it raises the question, are we the ones observing, or are we being observed by something deeper? Some ancient process that links stars and planets in quiet chemical ways. This is not a conspiracy or a tale of intention. It's simply the quiet recognition that the universe is always in motion, and sometimes two objects separated by billions of years and trillions of kilometers draw near, just long enough for their stories to intersect. Mars keeps its secrets well, but it also invites us to keep watching, to keep wondering, and so we do. We watch the skies, looking not just for the known planets and moons, but for the silent travellers, the ones who cross the darkness slowly, unannounced, leaving only a trace of reflected light and a brief alignment in the map of orbits. Mars, more than any other planet, seems to wear the light of the cosmos in a special way, not in a brilliant shine like Venus, or the mirrored flash of icy moons, but in a soft, dusty glow. Ancient light touches Mars differently. On Earth, we measure the sun's light by the time it takes to reach us, about 8 minutes. On Mars, the sunlight is weaker, colder, more filtered by distance. It takes just a few minutes more, but those minutes are enough to change everything. The shadows are longer. The sky is a soft butterscotch hue, not blue, and when starlight drifts in from the distant galaxy beyond, it has to pass through thinner air, whispering through carbon dioxide and ancient dust, unchanged for eons. We can imagine it now, standing in the highlands of Mars, under a sky painted by thin atmosphere and late sun. The horizon stretches low and wide, and above it the stars burn steady. No twinkling here, no shimmer from weather or water vapour, just the pure, cold signal of distant fire. And into that sky, perhaps for a moment, came Atlas. To our eyes on Earth, Atlas was barely a trace, an arc of motion against the glitter of background stars. To Mars it would have appeared as a slow crawler across the heavens, dim, perhaps invisible, but present. A silent visitor moving through a quiet dome. What's beautiful about this scene is not just the science, but the scale of it, the way ancient light plays on an old surface. Mars is a planet carved by time. Its highlands are older than any earthly mountain range. Its basins were shaped in an era when Earth was still molten and wild, and the light falling across it, sunlight, starlight, perhaps the pale reflection off the surface of Atlas, has taken years, sometimes centuries, sometimes billions of years to arrive. This is the rhythm of deep time. On Earth, we live in fast cycles, days, weeks, seasons. Even our longest histories feel brief compared to the geological hush of Mars. But on Mars, the rhythms are patient. Light rises and fades, dust settles and stirs, and occasionally a passing object, something not native to this star, not born of this family, moves across that still canvas. The composition of this light matters too. Photons from ancient stars scattered through the interstellar medium land gently on Mars's surface. Some bounce back into space, some sink into dust, some are captured by the optics of orbiters circling silently overhead. And in that mix of light, a story is told. Light carries information about chemistry, about motion, about distance. The faint spectral fingerprint of Atlas, even if briefly detectable, would have revealed something about where it came from, what it's made of, how long it has travelled. Most interstellar objects are too faint for such detailed study, but even a sliver of data, a flash of light caught by a vigilant telescope, can reveal volumes. It's like hearing a single note from an unfamiliar instrument. You may not know the whole melody, but you know it didn't come from your own orchestra. In the case of Atlas, it appears to carry icy material, similar to comets. That suggests a cold origin, perhaps the outer reaches of another planetary system, or even the dim edge of a rogue disk torn from a young star. It's this frozen composition that links it gently to the early solar system. Because our comets too are frozen messengers, relics of formation, unchanged for billions of years, and so, in its makeup, Atlas is both foreign and familiar, a reflection perhaps of what our own system might look like from a distance. When ancient light meets ancient surface, something quiet happens, not a collision, but a resonance. And when we think of Atlas brushing near Mars, we might imagine, not contact, but harmony, a brief alignment in the geometry of space, a soft moment when an old world and a drifting fragment share the same sky. The question of what does it want with Mars becomes less literal and more lyrical. Maybe it wants nothing, maybe it's simply passed, but maybe in the quiet architecture of the cosmos that passing was part of a pattern, a rhythm, a drift. We tend to look for purpose in proximity. When things come near each other, whether people, planets, or icy travellers from the void, we wonder what it means. And in space, perhaps, nearness is its own message. Long before Mars bore riverbeds or frozen caps, before even the sun had fully bloomed into light, the universe entered a hush we now call the cosmic dark ages. This was a time when no stars yet burned, no galaxies spun, only cooling hydrogen drifting in vast, silent clouds waiting. Eventually in that quiet, the first stars flickered into being. Massive, short-lived and luminous, they pierced the darkness like fireflies in a cave. That era, the cosmic dawn, began the long arc of structure and story. Why begin here, so far from Mars and Atlas? Because the material that makes up everything, the dust on Mars, the ice in Atlas, even the molecules in our own breath, was forged in those early fires. Atlas, though a visitor, is made from the same deep time. It's possible, maybe even likely, that its journey began billions of years ago. Long before our sun had planets, long before Mars was red. Somewhere a star system collapsed or scattered, and a fragment was sent adrift. Perhaps it circled its home star once, twice, then was flung outward by a gravitational nudge. That nudge could have come from a giant planet, a passing star, or the chaotic collapse of a forming system. This kind of quiet expulsion happens more than we might think. In the chaotic early stages of solar system formation, not everything stays bound. Some fragments are caught in loops, others are cast free, cold voyagers carrying chemical memories of their origin. Atlas could be one of these, a child of an ancient system, now far dissolved, sailing the interstellar medium alone. Its icy body may contain exotic compounds, super volatiles, that don't exist in comets born near our sun. Traces of heavy elements, frozen gases, or even organic molecules that differ just enough to catch our notice. We don't yet know, of course. It's faint, fast, hard to pin down. But the very idea invites wonder. If we could retrieve a grain from Atlas or simply capture its full spectrum, we might glimpse the fingerprints of a system far older or stranger than our own. This brings us to another thread in the pattern, the possibility that these interstellar fragments are not rare. In fact, some astrophysicists now believe that our solar system is constantly drifting through a quiet blizzard of such material. Not dramatic objects like Oumuamua or Borisov, but smaller things, pebbles, grains, drifting silently. If true, it means our solar system is more permeable than we thought, that the membrane between here and out there is thin, and Mars, because of its position and atmosphere, may be an excellent net. It doesn't burn up objects as completely as Earth does. Its atmosphere is too thin for that. Small fragments may land gently or break apart high above, scattering particles onto the surface. Over billions of years, Mars may have accumulated a quiet collection of dust from distant stars. Tiny bits of ice, carbon, metals, layered into the soil, waiting to be read like a cosmic diary. Atlas in this context is just one page, but a page with a title, a page we can see and name, and if it had drifted just slightly closer, it might have joined that hidden archive. A whisper added to the dusty vaults of Mars. There's a kind of melancholy to this idea. These visitors come so far only to miss, only to sail past in silence, but that melancholy is part of the beauty. Because the universe doesn't operate on our sense of story. It moves on its own timeline, its own rhythms, and every now and then those rhythms bring strangers together, even briefly, like Atlas and Mars, like us and the ancient light we see in the sky. We are all drifting fragments, in a way, held loosely by gravity, nudged by time, shaped by the echoes of early stars, and as we look up or look out, we do what beings like us have always done. We wonder, could that fragment hold secrets? Could that red planet remember things we've forgotten? We don't need firm answers to feel the depth of those questions. Sometimes, the wondering itself is enough. Gravity is not loud. It doesn't shout, doesn't flash, doesn't leave visible trails in the sky, but it is persistent, patient, inescapable. It shapes the motion of every object in space, from galaxies down to drifting grains of dust. And when it comes to travellers like Three-Eye Atlas, gravity becomes the quiet composer of the journey. Imagine this. A tiny icy object, perhaps no larger than a mountain, drifting through the void. It is not pulled by engines, not guided by will. It moves solely because of momentum and gravity. The moment Atlas crossed the invisible boundary of our solar system, it entered a domain where the sun's gravity became dominant. But the sun is not the only player. Every planet, every moon, every large object exerts a pull. Most are too weak or too far to matter much, but some, like Jupiter, are strong enough to alter a path entirely. Mars, though smaller than Earth, still has enough pull to bend a passing object's trajectory. And that's exactly what it may have done. It's likely that Atlas never came close enough to be captured, but it was gently nudged. A fractional curve in its arc, a subtle change in speed, perhaps enough to alter its outbound journey by thousands of kilometers. We sometimes imagine gravity as a tether, a string holding planets to the sun, moons to planets, and so on. But it's more fluid than that. Think of it more like a tide, not of water, but of motion, a tide that pulls differently depending on mass, distance and time. And for interstellar objects like Atlas, the journey is shaped by these subtle currents. Back when it first approached our system, Atlas would have been moving fast, so fast that it couldn't be trapped by the sun. Its speed would have exceeded what we call escape velocity. That's how we know it's not from here. It's not looping in an ellipse like comets do. It's slicing through in a long hyperbolic curve, one entry, one exit. But even a fast traveller feels the soft pull of gravity. Not enough to stop it, but enough to shape its path. And if that path curves near a planet like Mars, the effects become more intricate. There's a concept in celestial mechanics called gravitational assist. We use it often in spacecraft navigation. A probe swings past a planet to steal a little energy, slingshotting into a new trajectory. With Atlas, the principle is the same, except there's no guidance, no mission, just motion and mass. As it curved near Mars, the planet's pull may have tilted its path slightly, changing its angle relative to the ecliptic, adjusting the timing of its outbound arc. These changes may seem tiny, but over distances measured in light years, they add up. A nudge from Mars today might mean a detour across entire regions of interstellar space centuries from now. What's remarkable is how precisely we can model this. With enough data, astronomers can simulate these interactions down to meters and minutes. We can map where Atlas came from, where it will go, how close it came to Mars, and how much that encounter reshaped its future. Of course, our models have limits. Small variations caused by outgassing, unknown mass distributions or unobserved objects can shift the picture. But the core idea remains. Mars didn't just witness Atlas's passing, it participated. Even if the interaction was slight, it was real. A moment of gravitational dialogue between a frozen interstellar fragment and a world that has waited billions of years for such visitors. And this leads us to a softer reflection. How many times has this happened, unseen? How many fragments have curved silently through the solar system, their paths bent just slightly by planets like Mars or Earth, then vanished into the night? We only notice the brightest, the nearest. But space is not quiet. It is constantly whispering in the language of motion. And in that language, Mars is a participant, not just a destination, but a shaper of paths. Perhaps in another star system there's a red world like ours, watching its own visitors drift past. Objects like Atlas nudged by ancient gravity, carrying pieces of elsewhere across endless dark. It humbles us to realize how connected it all is. One curve near one planet, one moment in a trillion-mile journey, becomes part of a new path, a soft redirection that could ripple into distant futures, all done not with force, but with patience. Gravity never hurries, it simply waits and pulls and guides, and that's what may have happened quietly between 3i Atlas and Mars. If we could stand on the surface of Mars, just for a moment, in a still evening as the sun slips low behind the hills, we might look up and see a sky very different from our own. There is no blue, no thick clouds rolling in, no soft shimmer of atmosphere stirring above. Instead, the Martian sky is tinted in tones of pale rust and amber, gently scattered by ultrafine dust. As the day fades, it shifts into violet and dusk red, framing the stars with extraordinary clarity. This is where 3i Atlas would have appeared, if only faintly. A tiny moving speck drifting across that quiet sky, not trailing a visible tail, not flashing like a meteor. Just a dim fragment gliding across constellations that look strangely familiar but subtly shifted. Even on Earth, only the most sensitive instruments caught it. On Mars, without watchers, it passed unmarked. But let's imagine otherwise. Let's picture ourselves beneath that vast canopy. The air is thin, every breath strained, but the silence is extraordinary. The stars don't twinkle here. There's no weather to disturb their light. The Milky Way stretches out clearly, etched across the sky like a slow river. And within that river something moves. Atlas would have crossed the Martian sky not in a blaze but in a hush. A traveller just passing through, indifferent and unreachable, but somehow noticed. The idea of watching from Mars is of course poetic. The rovers do not look up. The landers do not scan the skies in real time. But in imagining that quiet moment, we connect with a deeper sense of scale. Because what would it mean to see such a thing? A visitor from outside the sun's family, gliding above a planet that has already known so much silence. Mars has seen its share of motion, moons arcing, dust devils swirling, meteors striking. But an interstellar object is something different. It's not from here, it's not from anywhere near here. And to watch it from that red surface, across a horizon scored with old riverbeds and dried lake beds, would be like catching sight of a message in a bottle, far out at sea. It doesn't speak, but it implies, it suggests. As the object moves across the Martian sky, it does so at a pace we might call patient. Not the flash of a meteor, but the slow progress of a star that moves when others do not. Perhaps it crosses a familiar constellation, or slips near Deimos, the smaller of Mars's moons, which looks more like a star than a moon to the naked eye. There's a moment of alignment. Object, moon, horizon, then it's gone. These are scenes we can't photograph, not yet, but they live in the realm of imagined astronomy, where what we know feeds what we feel, and what we feel in that imagined Martian dusk is a kind of serene loneliness, a sense of being both close to something immense and very far from everything familiar. Even our machines wandering across the surface carry this mood. Rovers like Perseverance and Curiosity, slow rolling on quiet wheels, navigating a world where nothing moves unless the wind wills it. They scan rocks and gather soil, but they don't look up to see objects like Atlas. They're busy with other stories, and yet, somehow, we look up on their behalf. We project our own wonder onto their metal bodies. We imagine that even machines in their stillness might share the awe. Atlas passed, and Mars turned beneath it. Whether the path was near or far in the grand scale hardly matters, because the sky is wide and time is generous. What matters is that for a brief while, this old red world and that cold interstellar fragment shared a frame of reference, a window of visibility, a moment. And in that moment, the silence between stars felt a little smaller, not because of noise or contact or meaning in the usual sense, but because of movement, alignment, presence. It's humbling to imagine how often this must occur, how many objects pass quietly through skies we do not yet watch. And it's soothing too, because not every story needs a beginning and end. Some just pass through, and that is enough. The Martian atmosphere is a veil, a thin, trembling film of carbon dioxide and dust that wraps the planet not in protection, but in memory. It doesn't behave like Earth's atmosphere. There's no roaring wind, no thunder, no dense clouds rolling over cities. On Mars, the air barely whispers, yet that whisper carries stories. If 3 Atlas had entered deep enough into this atmosphere, we might have seen a quiet fading. Not the kind of fiery descent we know from Earth meteors, but something more fragile, a slow disintegration, as outer layers peeled away molecule by molecule. But Atlas didn't come close enough for that. Still, it makes us wonder, what if it had? The Martian atmosphere is about 1% as dense as Earth's. It's just thick enough to carve subtle trails in high-altitude ice. Sometimes, when comets or meteoroids skim its upper layers, they leave brief, glowing paths, soft arcs that curve and vanish. These are not explosive. They're often invisible to the eye, but in the right conditions, under the right lighting, they might shine for a heartbeat. And even that possibility gives shape to imagination. What if Atlas brushed the edge of that veil, glancing across the Martian sky like a match flicked in the wind, glowing softly for just a moment, then fading without impact? No crater, no debris field, just a subtle ionization trail, ghostly and cold, soon erased by the ever-settling dust. On Mars, entry events are gentler, but also more mysterious. We've seen meteors that came and went without a mark. Others leave tiny punctures in the regolith, detectable only by careful orbiters. It's plausible that, over millennia, fragments from other systems have touched the planet and vanished unremarked. The thin air slows them, but not always enough to stop them. In fact, small objects sometimes survive impact better on Mars than on Earth, because they experience less heat from friction. So even though Atlas passed too far to enter the atmosphere, the question remains open. How many others have come and gone unnoticed? The atmosphere also gives us another gift: dust. Mars's fine dust is electrostatically active. It clings, it hovers, it moves in slow, unpredictable waves. Sometimes it lifts into great storms that wrap the planet. Other times, it simply hangs, veiling the sky. This dust, so ever-present, would play a role in any near pass by an object like Atlas. Even without entry, the gravitational pull of a close object might stir the atmosphere just enough to disturb local patterns. Could it be measured? Probably not easily, but the idea that something from another star might slightly agitate the dust of Mars is strangely beautiful. Imagine, for instance, a high-altitude swirl, so faint that no instrument could register it. A ripple of motion in a planet's skin caused by a passing visitor no one sees. We often think of space as clean, but it's not. It's dusty, it's tangled, it's rich with debris. And Mars, because of its air and position, is uniquely poised to record those whispers. There are missions now that study the upper atmosphere of Mars like MAVEN. They track escape rates of particles, examine the interactions of solar wind with the magnetic ghost fields, and scan for minute changes in composition. It's possible, just barely, that an object like Atlas could leave a trace in those readings. A spike in ionization, a faint variation in pressure, a shift in dust drift, and if so, those would be the fingerprints of a moment when two great silences met. One silence is Mars, old, waiting, with thin breath and long memory. The other is Atlas, cold, distant, shaped by billions of years and aimless in its travel. And where they nearly touch, something delicate may happen. Nothing we'd see from Earth, nothing dramatic. But a fleeting resonance, a soft tremble in the veil of air, like the pause between notes in a long-forgotten song. It reminds us that not all interactions leave bold marks. Some leave quiet ones. Some are more about proximity than consequence. And in that sense, Atlas's pass near Mars becomes more than geometry. It becomes a story about thresholds. What comes close enough to be felt, but not touched. What stirs, but doesn't strike. And how even in the thinnest air, a presence can leave behind a question. Out on the open face of Mars, the land seems still. The canyons don't crumble, the rocks don't roll, and yet, every so often the whole planet seems to breathe in dust. Dust storms on Mars aren't like the churning tempests of Earth. They build slowly, they rise in spirals, they begin in silence and can grow to cover entire hemispheres, even the whole planet veiling the surface beneath a blanket of pale rust. Imagine for a moment Three-Eye Atlas drifting near Mars while such a storm is rising. From afar, the planet might appear to blur, its once clear surface turning soft and featureless. The lines of craters and ridges fading beneath a moving haze. To an observer above, Atlas might glide across this dusty veil like a bird over fog, its presence unseen, but its motion strangely synchronized with the storm below. Dust storms on Mars begin with sunlight. When the sun heats a patch of ground, warm air begins to rise, carrying fine particles with it. And because the Martian atmosphere is so thin, those particles don't settle quickly. They hover, they drift, and they lift more dust in turn. A local swirl becomes a regional storm becomes global, and suddenly, what was once a clear view becomes a world cloaked in shadow. The last time this happened on a global scale, it was 2018. The storm was so thick and lasting that it silenced NASA's Opportunity rover after nearly 15 years of service. Its solar panels were choked in dust and its voice fell quiet forever. If Atlas had passed near Mars during such a storm, it would have looked down upon a red world gone dim. Not dark in the usual sense, but muffled, its features erased, its contrast lost, a soft mask of mineral breath rising skyward. Could a passing interstellar object affect such storms? Not in any obvious way. Atlas is small, and the Martian atmosphere vast, even at its thinness. The scales are mismatched, but proximity stirs questions. For instance, if an object passed close enough, could its gravity nudge atmospheric layers? Could it slightly alter wind patterns? The answer is, perhaps. But it would be subtle. Subtler than we can yet measure. Still, the idea lives. Picture a high-altitude streamer of dust, already rising, then briefly accelerated by an external tug. Not enough to change the storm, but enough to slightly shift a strand of it. A gesture, not a command. And in such a world, where dust can remain aloft for weeks, even that soft nudge becomes part of the story. This interplay between storm and sky also reminds us how much of Mars's memory is buried. When dust moves, it doesn't just veil the surface. It erases tracks, it fills craters, it buries fragments. A meteorite that falls during a storm may vanish within days, hidden beneath drifting layers, protected from further erosion. So, what of interstellar grains? If a fragment of Atlas had broken loose during its passage, something small, no bigger than a seed, it might have fallen gently through the dusty air, landing amid storm or stillness alike. There it would rest, indistinguishable at first from Martian soil. Just one more grain among billions, but chemically it would be different. Alien. And if we had the instruments, if we could sweep the surface carefully enough, we might find that grain. We might learn from its isotopes or its crystalline structure that it came from another star. There is precedent for this. On Earth, some meteorites contain material older than the solar system. Tiny pre-solar grains, embedded in carbon matrices, carried to us by comets or asteroids. They're rare, but they exist. And so, Mars may have such relics too, some delivered by chance. Others perhaps as passengers on forgotten objects like Atlas. The planet's stillness becomes its strength here. With no oceans to churn, no tectonics to recycle crust, Mars preserves. It keeps its wounds, its layers, its buried whispers. Perhaps beneath a few millimeters of storm-settled dust, there lies a shard of Thule Atlas. Not enough to make headlines, but enough to answer one question one day for the quiet scientists who dig carefully in cold red soil. And so, as we picture that storm swirling across plains, whispering through canyons, we wonder what else it hides, not just from us, but from Mars itself. The farther we drift from Earth in our thoughts, the more delicate our grasp becomes, not just of what things are, but of what they're made of. We know, for instance, that comets from our own solar system tend to be composed of volatile ices, water, carbon dioxide, ammonia, along with silicate dust and organic molecules. They are ancient time capsules, remnants of our own beginning. But interstellar objects, that's a different story. We've only glimpsed a few. Oumuamua, Borisov, and now Atlas. Each has offered us fragments of knowledge, glimpses of chemistry and motion, but the full compositions remain largely out of reach. For Borisov, we could observe its coma and tail, glowing with cyanogen, water and other familiar gases. It looked, in many ways, like comets we'd seen before. But there were differences too. Its dust grain sizes were odd, larger, more numerous. Its chemical ratios didn't match what we'd expect from our own Kuiper belt. Oumuamua was more mysterious still, no tail, no visible outgassing, but it still accelerated slightly as it left the sun, something normally caused by sublimating ice. But if there was ice, we never saw it, and if there was gas, it was too faint to detect. Atlas sits somewhere in the middle, not as bright or strange as Borisov, not as enigmatic as Oumuamua, but still undeniably foreign. Its spectrum hinted at carbon-based compounds, its tail was barely visible, and its surface, though distant, seemed to reflect light in ways that suggested a fragile structure, perhaps porous, perhaps fragmentary. In short, we're not sure what Atlas is made of, but that uncertainty is where the wonder lives, because if interstellar objects differ from those in our own system, it means that planetary systems across the galaxy forge materials in subtly different ways. Different stars produce different ratios of heavy elements. Different protoplanetary disks cool at different speeds. Different gravitational arrangements fling fragments outward with different energies. And so, each interstellar traveller becomes a sample, not of one object, but of an entire stellar ecosystem. When Atlas passed through, it carried a chemical fingerprint from a place we'll likely never visit. It may have formed near a red dwarf star, or a bright short-lived giant. It may have passed through ionized gas clouds. It may have been irradiated, cracked, reshaped. Every micron of its surface could hold traces of that long history, and yet, we can't reach it. Not yet. We can observe. We can calculate, but we cannot touch. That distance is humbling. Still, the curiosity remains, because in those icy fragments might lie answers to old questions. Are carbon chains common across all systems? Do other solar nurseries form amino acids like ours did? Are there unknown compounds, foreign molecules not yet imagined by our chemistries? Some scientists dream of missions that could intercept these wanderers, catch up to them, sample them, bring back a piece. The technical challenges are immense, the windows are narrow, the speeds involved are staggering, but the payoff would be enormous. Because with even a gram of such material, we could look back billions of years and light years into the origins of distant planets. Until then, we make do with what we can gather: spectral lines, motion curves, faint glows across wide telescopic arrays. Each measurement tells us a little more. Each traveller becomes a data point. And with each one, our sense of what typical looks like begins to shift. Because maybe, just maybe, our solar system is not standard. Maybe it's unusual. Maybe water worlds like Earth are rare. Maybe dry, silent planets like Mars are more common. Or maybe we're all echoes of the same cosmic pattern, written in slightly different scripts. In any case, Atlas helps us widen the lens. It reminds us that what seems exotic today may one day feel familiar. Just as once, the idea of Mars having ice beneath its surface was radical, and now it's expected. We're always updating our maps, not just of space, but of possibility. And every strange object we find, every spectrum that doesn't fit, every curve that doesn't close, brings us closer to the truth, or at least to better questions. Beneath Mars's windswept plains and cratered highlands lies something precious: ice, frozen water, trapped in layers beneath the surface, lingering in the shadows of ancient gullies and polar caps. This ice has been studied for decades, its presence confirmed by orbiters and rovers, its texture inferred by radar and spectral scans. In many places it lies just centimetres beneath the dust. In a world so dry, this buried memory of water feels like a secret, a whisper that perhaps, in its deep past, Mars was something more than the barren silence we see today. And that whisper becomes louder when we consider the idea of interstellar chemistry, because in this frozen crust of Mars, and in the icy heart of visitors like 3i Atlas, we glimpse a strange echo, a shared language between worlds. It's in the way water forms, clings and carries, in the molecules frozen into comets, and the trace volatiles embedded in Mars's regolith. It's not just about the presence of ice, it's about the ingredients that may come with it. We know that water ice can trap gases, can preserve organics, can hold, locked within its crystal lattice, the fingerprints of the environment in which it formed. On Earth, ice cores tell us stories of the atmosphere centuries ago. On Mars, the ice does something similar, though its story is far older and far less complete. Now imagine 3i Atlas, a visitor formed in the far reaches of another system, its surface frosted in ancient ices, rich with exotic traces, perhaps unfamiliar ratios of nitrogen, methane or rare carbon chains. If it had touched Mars, if even a tiny fragment had settled onto its surface, nestled among frost and dust, what story might it bring? There's a theory, cautious but persistent, that icy objects may serve as vessels, not of life itself, but of life's building blocks, amino acids. Carbon chains, prebiotic molecules. On Earth, such compounds have been found in meteorites, carbonaceous chondrites that fell from space, carrying chemical patterns not made here. If these molecules can survive the cold of interstellar drift and the gentle descent through a thin atmosphere, then Mars may be more than a barren listener. It may be a collector, a quiet archive of cosmic chemistry. We can't say whether Atlas delivered anything. Its path was too distant for contact. But Mars has been orbiting for over 4 billion years. That's a long time to gather things, and its stillness is a kind of strength. Unlike Earth, it has no flowing water to erase old layers, no plate tectonics to bury history, no forests or oceans to recycle the past. What lands on Mars tends to stay, preserved by cold and quiet. So if, long ago or far in the future, another fragment like Atlas finds itself captured by Mars's gentle pull, it may join the frozen deposits already there, and in doing so, it might bring a new compound, a new pattern, a subtle anomaly that hints at chemistry born in another corner of the galaxy. These are not loud discoveries. They don't erupt or glow. They lie dormant, waiting, perhaps buried beneath a few inches of dust. Perhaps invisible until we dig, but they matter, because they offer a kind of proof, not of life, not yet, but of connection. A link between planets, between systems, between pasts we can't fully know. It's comforting to think that Mars may hold such things, that beneath its quiet surface there might be a record, not just of what happened here, but of what drifted in from elsewhere. Somewhere, a frozen ridge or shadowed crater might hold a molecule that began its story under a different star. And in that possibility, the silence of Mars becomes not emptiness, but anticipation. Above the dust and ice of Mars, 2 moons drift silently through the sky. Phobos and Deimos, irregular, cratered and dark, circle the planet like forgotten shadows. They're not like our moon. They're far smaller, more fragile in shape. Phobos is only about 22 kilometers wide, and Deimos even smaller. Their surfaces are mottled, as if carved from ancient charcoal. They may be captured asteroids pulled in long ago by Mars's gravity, or they may be remnants of a larger moon, shattered and scattered in a distant collision. Whatever their origin, they are constant companions, always overhead, always moving, though not always visible. And when we think of 3i Atlas drifting past Mars, we might pause to wonder, did it cross paths, even fleetingly, with one of these moons? The odds of a direct interaction are vanishingly small. Space is wide, and these moons are tiny. But alignment doesn't always require contact. Imagine this. Atlas glides through space near Mars's orbit. Far below, the red planet turns slowly. Between them, Phobos orbits, fast, close, completing a lap in less than 8 hours. There could have been a moment, a brief geometric alignment when Atlas passed behind one of the moons, casting a soft silhouette. From the perspective of a Martian observer, it might have looked like a faint star momentarily vanishing behind a moving black pebble, or perhaps Atlas passed in front of one of the moons, its dim outline crossing the cratered face like a shadow within a shadow. These transits would be almost impossible to detect with our current instruments, but the idea alone carries a certain grace, because in that fleeting intersection, moon, fragment, planet, we glimpse how cosmic paths can momentarily overlap, even when separated by thousands of kilometers. Such moments don't leave marks, no trails, no residue, but they create patterns in space, like footprints in dust that vanish as soon as they're made. Phobos, the larger moon, has a strange feature, a long groove pattern etched across its surface, like stretch marks. Some scientists believe these are stress fractures, signs that the moon is slowly breaking apart. One day it may crumble, becoming a ring around Mars before dissolving completely. Deimos, farther out, is quieter. It takes 30 hours to orbit and looks almost still against the sky. These moons, like Atlas, are remnants, pieces of something older, something fragmented, and so it's poetic to imagine them together in one frame, even just for a moment, even just from afar. Their encounter would be wordless, but full of implication, because moons, like planets, can influence passing objects, gravitationally, if only slightly. Atlas's trajectory was likely unaffected by Phobos or Deimos. Their mass is too low. But the passage through their orbital corridors links their stories, however briefly. One might even imagine a future mission, an orbiter circling Deimos, scanning the Martian system, catching a faint anomaly in the distance, a glint of motion, a dot against the stars not behaving like anything native to the system. That's the power of proximity. It makes even the faintest visitors feel real, and in the grand ledger of cosmic motion, even these tiny moons play their part. Because everything that moves casts influence. Every orbit bends light, warps time, nudges dust. If Atlas passed near the path of Phobos or Deimos, even its faint gravity might have caused an almost imperceptible ripple in their orbits. Or maybe it stirred nothing. Maybe it passed entirely unnoticed. But the idea remains, an imagined transit, a silent choreography in the Martian sky, a moment where a drifting fragment from another star crossed paths, if only by angle and light, with two moons that have only ever known the red planet's pull. In these imagined alignments we find a kind of peace, because the universe doesn't always shout its connections. Sometimes it whispers them, through shadow, through motion, through the gentle timing of objects that never touch, but still share the same sky. In the quiet architecture of space, there are places where balance lingers. Not the balance of stillness, but of subtle motion, where gravity's tug from two bodies cancels just enough to create a pause in the drift. These places are called Lagrange points. For Mars, as with Earth and other planets, there are 5 of them, zones where the gravitational pulls of the planet and the Sun combine in just the right way to allow an object to hover, to follow, or to lead. The Lagrange points are invisible, but their presence is real. Objects placed there can remain for long periods with only minor corrections, coasting on the soft tide of gravitational equilibrium. Some of Mars's Lagrange points are already known to host material. At its leading and trailing edges, L4 and L5, there may be small Trojan asteroids, caught in step with the red planet as it orbits the Sun. Others, like L1 between Mars and the Sun, or L2 beyond the far side of the planet, offer regions where spacecraft can hold a stable view, or where dust might collect. Now, imagine 3i Atlas entering this gravitational ballet. Its hyperbolic orbit likely carried it past Mars too quickly to become trapped, but still, we can ask, could it have passed through one of these balance points? And if so, what might it have seen? Or perhaps become? Lagrange points are not still waters. They are dynamic, especially for objects moving at great speed. But some regions, particularly the triangular points L4 and L5, can be surprisingly stable. They act like eddies in a slow river, catching debris in their gentle spirals. If Atlas had passed near one of these zones, its path might have briefly aligned with the local flow of motion. For a moment it might have drifted in sync with Mars's orbit. Its motion eased, its relative speed slowed, and then, inevitably, it would have slipped free again, pulled onward by its immense interstellar momentum. We can imagine that moment, Atlas gliding through an invisible corridor, a region where the Sun and Mars seem to whisper in unison, "Stay," but it doesn't stay. It never could. Still, the encounter leaves a trace, not physical, but theoretical, a waypoint in its long arc through space. These gravitational pause points raise another question. How many visitors have stayed? If small interstellar objects pass through solar systems frequently, as some models suggest, could some of them be caught, not by planets, but by Lagrange points? Could our solar system be hosting silent guests, held in these balance zones for millennia, never noticed, never catalogued? We've found some objects, Trojans at Jupiter's Lagrange points, co-orbitals near Earth. But how many more drift in quiet suspension, neither falling nor fleeing? Perhaps Mars too has such a companion, a small rock, dim and slow, trapped at L5, orbiting just ahead of the planet, unseen by our limited surveys. And maybe, just maybe, one of those objects is not from here. Not all visitors blaze past. Some linger. The Lagrange points teach us that space is not all extremes, not all collisions and escapes. There are eddies, havens. Places where an object like Atlas might have rested if only the angle were right. The speed just so. To us, it passed through. A blur, a name on a list. But in the precise corridors of Mars's gravitational map, it left its trace, an echo in equations, a curve in the chart, a story written in decimal points. These are the places we forget to look, the quiet hollows of balance tucked between giants. But the cosmos remembers them. It builds them into every system, every pair of orbiting bodies. They are the unsung geometries of the sky. And when a wanderer like Atlas enters that field just for a moment, it becomes part of that silent architecture. It becomes part of the Mars system, not as a resident, but as a passerby who knew, however briefly, the rhythm of its balance. Light is the language of astronomy. Everything we know about stars, about planets, about distant galaxies and drifting fragments comes from how light moves, how it bends, how it fades. Even objects as silent as Three-Eye Atlas leave behind a trace of their presence through light. Not bright, not flashy, but measurable. When it passed near Mars, Atlas reflected sunlight. That light, once emitted by our star and scattered from the surface of this visitor, travelled millions of kilometres before reaching our instruments. It wasn't much. A faint glimmer, hardly more than noise at first. But with patience and care, astronomers were able to detect it, to confirm its path and to mark its origins as beyond the sun's pull. This reflection told us something vital. The object is real. It's not a calculation, not a theory. It's a fragment moving through the sky, obeying laws of motion we've come to know, but shaped by a past we cannot trace. Light is more than just a signal. It's a fingerprint. From that faint glow, scientists extracted data about the object's surface, how much light it reflects, how its brightness changes as it turns, how quickly it fades as it moves away. Atlas's light curve was unsteady, not smooth, which suggests a rotating body, irregular in shape. Perhaps not a whole object, but a fragment, perhaps tumbling as it travels. Its colour too matters. Icy comets often reflect more blue light than rocky asteroids. Atlas seemed to show signs of carbon-rich material, similar to some comets, but different enough to keep us wondering. And then there's redshift. Objects moving away from us stretch the wavelengths of light they reflect or emit, shifting them toward the red end of the spectrum. This is how we know the universe is expanding. Galaxies farther from us are more redshifted. For Atlas, the redshift is subtle. It's not a galaxy after all, but the principles still apply. By measuring the shift in its reflected light, scientists can calculate its velocity, how fast it's moving, and in what direction. As it passed near Mars, Atlas was still outbound, on a path away from the Sun. Its speed, its angle, its distance, all of it confirmed that this was not a solar system native. It came from elsewhere, and in passing it offered a rare opportunity to see interstellar light, altered by interstellar chemistry, passing through a solar system not its own. Even more fascinating is the potential for gravitational lensing. While Mars is not massive enough to lens light in any dramatic way, there's a poetic truth here. Every mass bends the path of light, however slightly. In theory, if Atlas passed behind Mars, relative to an observer in the right location, its light could have been ever so gently curved, altered by the planet's presence. We may never detect that bend. It's too small for our current eyes. But it happened if the alignment was right, and in that invisible curve lies a quiet echo of relativity. Because every photon that touched Atlas and then passed near Mars was not moving on a straight line. It was curving, adapting, responding to mass and space and time. This is the soft poetry of astronomy, the understanding that even a passing speck reflects and refracts the ancient laws of the cosmos. It reminds us that observation is not passive. To see is to interact. Even a faint beam of light once detected becomes part of our understanding, part of the object's story. Mars, too, observes in its way. Its orbit has held steady for eons. Its gravity, its thin air, its stillness, they all influence what can be seen from and around it. If we had been there, on the surface with a sensitive instrument, we might have caught Atlas's glint, a brief brightness among the steady stars. A signature from far away, fading as quickly as it arrived. But even here on Earth, across millions of kilometers, we saw it. We measured. We traced. And that light, those few reflected photons, linked us, briefly, to something that began its journey far before we were watching. Out in the vast quiet between stars, chemistry doesn't sleep. It continues slowly, invisibly, in icy fragments and dust grains, shaping the potential for life long before any spark begins. And when we think of 3i Atlas, this quiet interstellar traveller, it's not just the orbit or light that draws our interest. It's what it might carry. Not life, not consciousness, but the ingredients of possibility. In the past, our comets have shown us that even frozen bodies, long dormant and drifting, can preserve complex organic molecules, amino acids, hydrocarbons, even sugars. The chemistry of life does not begin with cells. It begins with arrangement, how carbon bonds with hydrogen, how nitrogen slips into the spiral, how time and cold and pressure guide molecules towards structure. On Earth, the early ingredients of life may have come, at least in part, from space, delivered by comets or meteorites. These weren't miracles, they were messengers. And so, we wonder, could Atlas be such a messenger? Could it too carry chemistry shaped in the cold dark of another star system? The idea is known as interstellar panspermia, though not in the sci-fi sense of deliberate seeding. More like a slow exchange. Fragments drifting, crossing systems, dusting worlds with silent complexity. It's a theory still debated, still distant from proof, but it's not dismissed. In 2020, researchers discovered that the asteroid Ryugu, sampled by Japan's Hayabusa 2 mission, contained uracil, a building block of RNA, and nicotinic acid, a form of vitamin B3. These were not manufactured, they were preserved, waiting in carbon-rich rock since the formation of the solar system. So if these compounds can survive for billions of years, could they also survive a journey from one system to another? Atlas, moving fast, likely formed far away. Perhaps it was born in a dense, cold region of a molecular cloud, a nursery where stars and planets condense from cosmic dust. In such places, chemistry becomes layered. Ice forms on grains. Radiation alters bonds. Over time, complex molecules emerge, not through design, but through sheer abundance of time. And when a young system forms, not everything stays put. Some bodies are flung out, ejected by chaotic gravity, sent into the void as emissaries of ancient structure. That may be Atlas's story. If so, it carries with it not just ice and dust, but memory, a record of its origin pressed into its atoms. We don't yet have the tools to reach out and take a sample. But the idea alone stirs imagination. What if Mars, dry, quiet Mars, were one of the few places in our solar system to receive such chemistry? Its thin atmosphere wouldn't destroy the molecules. Its cold soil might even preserve them, and its stillness makes it a perfect archive. No tides to wash things away, no heat to burn them, no tectonic churn to bury them forever. Just dust, time, and silence. If even a single fragment of Atlas touched Mars, if it broke apart in flight or shed a grain of ice, it might have delivered something precious, and we might never know, not unless we dig. Not unless a future rover samples the right patch of soil, runs the right scan, and notices a compound that doesn't quite belong. Even then, the evidence would be delicate, the signature subtle, but the implication would echo across our understanding, because it would suggest that planetary systems don't just evolve in isolation, they communicate in a way, through fragments, through ice, through chemistry, not intentionally, not consciously, but through motion and time. In this view, Atlas is not alone. It is part of a slow exchange, a cosmic drift of material, crossing boundaries, mixing origins. And Mars, sitting quietly in its cold orbit, becomes not just a recipient, but a node in a galactic web. A place where molecules from multiple origins might mingle. A place where, in some buried layer of frost, two chemistries, one Martian, one interstellar, might lie side by side, waiting. Among the galaxies scattered across the universe, some are nearly invisible. They hold stars, yes, but they stretch them thin, like whispers across the dark. These are the ultra-diffuse galaxies. They are large, often as wide as the Milky Way, yet their starlight is faint, spread so sparsely that they appear like smudges on deep sky photographs. And it's here, in this concept of the barely seen, that we find a strange parallel with 3i Atlas. Because Atlas too is a thing defined by its faintness, a speck moving against the velvet sky, barely reflecting enough light to track. It passed through our solar system not with brilliance, but with subtlety, its signal requiring persistence, patience, and careful instruments to detect. This kind of invisibility isn't unusual in space. In fact, it might be the rule. Most of what moves in the universe escapes our notice. Most of what exists is hidden, from dark matter to the cold clouds between stars. And yet, these things shape the story. Ultra-diffuse galaxies challenge our ideas about how matter clumps. They seem too faint to hold together, too fragile to survive the pull of other galaxies. Yet they persist, some with dark matter halos, others mysteriously without. Atlas, on its own smaller scale, brings a similar riddle. It should behave like a comet, but doesn't. It should have a bright coma, but barely shows one. It moves like an interstellar object, yet carries familiar traits. Is it an ordinary fragment, or something more rare, something that hints at structures and systems we don't yet fully understand? When we try to spot ultra-diffuse galaxies, we look not for brightness, but for motion, for how stars within them drift. With Atlas we do the same. Its faint light alone is not enough, but its path gives it away, a hyperbolic trajectory, a velocity too high to be bound, a curve that whispers, "I am not from here." And it's the same with those ghostly galaxies. Their structure says, "I do not behave like the others." In both cases, faintness becomes a kind of signal, not absence, but subtle presence, not silence, but a softer note in a larger composition. This matters because it reminds us to listen differently, to look not only for the bright, the loud, the obvious, but for the quiet patterns that pass through unnoticed. Atlas teaches us, in its soft way, that some truths are not hidden by distance, but by delicacy. They're right in front of us, just harder to hear. Imagine the solar system from a distance, the bright glare of the sun, the neat orbits of planets, the comets flaring into temporary brilliance, and then, between them, a small grey fragment. Atlas, drifting through, too faint to dazzle, too fast to stay, but real, present, affecting gravity fields, leaving trails of data in observatories, slipping into charts, and then out again. It may have passed near other faint things too, undiscovered asteroids, Martian co-orbitals, bits of ancient rock too small or too dim to be found. The sky is full of these quiet players, and perhaps the true shape of our cosmic neighbourhood is drawn not by the bright or bold, but by the sum of these nearly invisible interactions. Just as ultra-diffuse galaxies fill the spaces between the giants, perhaps these fragments, like Atlas, fill the quiet between discoveries. They are not noise, they are structure. And so, we might say, the universe is not made of what we see. It is made of what we almost miss. And in that, there is a kind of peace, because it tells us that every glance we cast upward, every scan, every quiet night spent watching, is part of a deeper conversation, a way of hearing the soft voices, of honouring the faint light, and of remembering that sometimes the things that matter most are not the ones that blaze, but the ones that pass gently by, asking only to be noticed. In the great silence between stars, we often speak of objects like Three-Eye Atlas as wanderers, directionless, random, shaped only by motion and time. But sometimes the data leaves us unsettled, because not everything about these interstellar visitors fits our models. Some paths are too clean, some behaviours too subtle, and the more we observe, the more we ask, is it truly chaos, or is there a quiet pattern we haven't yet recognised? Astrophysicists still debate this, though gently. There's no grand consensus, but also no dismissal, just careful words, measured thoughts. Some wonder if these objects are flung entirely by chance, ejected by gravitational chaos, collisions, or the resonance of young planetary systems. Others consider the possibility of structure, that the galaxy, through its own rhythms and motions, might shape streams of interstellar debris. Imagine long arcs of fragments, flowing like rivers through the Milky Way, cold, quiet, invisible except in rare moments when one brushes past a star system like ours. Perhaps Atlas is one such traveller, not alone, but part of a broader procession. Already, some researchers suggest that Oumuamua and Atlas may have come from similar regions, perhaps even related in origin. Their trajectories are different, but there are echoes, similar velocity profiles, similar timing, enough to make us pause. Could there be a shared point of ejection, a region of space that millions of years ago released more than one of these objects toward our part of the sky? If so, what mechanism was at work? A dying star shedding fragments, a collision in a distant planetary system, or something stranger, some yet unknown dynamic in the galactic disk that occasionally exhales fragments toward the spiral arms? We don't know, but the patterns may be there, faint and slow, waiting to be seen. We're just beginning to map the flows of interstellar material, to notice when objects share traits. And as that map grows, new questions emerge. Are we drifting through a zone of higher interstellar traffic? Could certain regions of the solar system be more exposed to these passers-by than others? And if so, does that shape anything? Does it influence the history of impacts, the origin of organic material, the subtle layers of dust settling on moons and planets? These aren't just questions for theorists. They guide our observations. They shape how we plan missions, where we look, what data we save. If 3i Atlas isn't just a solitary traveller, if it's part of a broader pattern, then perhaps its arrival isn't incidental. Not intentional, of course. Not in the way humans plan, but part of a cosmic rhythm, a slow beat, marked in fragments. And it's here that imagination leans forward, just a little. Because even within the realm of natural processes, order can arise. A spiral galaxy is ordered, though its stars move independently. A magnetic field is ordered, though it's built from invisible forces. Why not, then, the paths of debris? Why not a stream of ancient fragments, cooled, cracked and distant, moving together, only revealed when one catches sunlight near a quiet red planet? Atlas reminds us of this possibility. It doesn't demand attention, but it invites consideration. Its trajectory, its composition, its timing, they leave room for doubt, and in that doubt wonder. Because if these visitors aren't random, then what are they? Echoes? Messengers? The debris of an ancient accident? Or are they the drifting punctuation of a sentence we haven't learned to read? Whatever the truth, we continue watching. Each object we discover is not just another speck. It's a clue, a voice, a data point on a chart that slowly perhaps begins to form a shape. And if that shape includes Mars, if these objects pass near it more often than we'd expect, then maybe the red planet is more than a waypoint. Maybe it's a listener, a quiet node in the drift, a place where fragments pause, where gravity brushes paths, where the galaxy's patterns find momentary form. Even in the silence of space, light bends. Not because of obstacles, not because of reflection, but because of gravity, mass warping space itself, guiding light as if through a curved lens. This phenomenon, called gravitational lensing, was one of Einstein's most beautiful predictions, and though it's often observed on the grandest scales, galaxies bending the light of more distant galaxies, it applies everywhere, even in the quiet orbit of Mars. Let's imagine 3i Atlas passing near the red planet. Not a collision, not even a close flyby, but an alignment just precise enough to allow the light from a background star to pass near both objects. From the right perspective, for the briefest of moments, that starlight would bend. The presence of Mars, its mass, its place in the fabric of space-time, would cause the light to curve slightly, not dramatically, not enough to dazzle, but just enough to shift the position of the star ever so slightly as seen by a distant observer. Atlas, too, contributes its own infinitesimal lensing. Every object, no matter how small, bends light. Even you, sitting still, bend space around you. But in practice, only the largest masses show measurable effects. And yet, if Atlas had passed at just the right angle, with just the right alignment, perhaps its faint gravity added a subtle ripple to that already gentle curve. These alignments are rare, but the cosmos is vast and time is patient. In fact, some researchers use gravitational microlensing to find planets around distant stars. When a foreground object moves in front of a background star, it can cause the star's brightness to increase briefly, focused like a magnifying glass. Could Atlas during its passage have created such a moment? Theoretically, yes. Detecting it, however, is another matter. We would have to be watching the exact right star, from the exact right place, at the exact right time, and even then, the change would be small, perhaps only a fraction of a percent in brightness, lasting hours at most. But in that tiny flicker lies a truth. Mass shapes light. Even this icy fragment from beyond the stars becomes for a moment part of the story of visibility. It reminds us that seeing isn't passive. Every observation is affected by the thing being observed and the things in between. In the case of Mars, gravitational lensing plays a quieter role. It's not massive enough to create strong lensing like the Sun, but its effect exists, and in theory the curved light paths near Mars could reveal distant stars, comets, or even passing interstellar objects in a new way. Future missions might exploit this. Imagine a telescope stationed near Mars, using the planet's own gravity to enhance its view of faraway galaxies, peering through curved space like a natural observatory. Or conversely, imagine a lensing effect helping us spot an object like Atlas before it reflects enough light to be seen. A brief shimmer, a temporary anomaly in the brightness of a background star, an interstellar object, not seen directly, but noticed by how it bends what lies behind it. This method is already used to study dark matter, massive halos around galaxies that we cannot see, but which reveal themselves by how they lens light. And so, Atlas joins that quiet tradition. A thing noticed not by its brightness, but by its influence. It did not speak, but it made space curve. And that curvature, gentle as it may be, is part of the greater fabric we're still learning to read. Mars becomes a player in this as well, not just a silent observer, but a participant in how visibility shifts. The red planet's own lensing, subtle though it is, might one day help us study things far beyond its orbit. It's a reminder that nothing in space is truly isolated. Every object, no matter how still it seems, affects everything around it, not dramatically, not always in ways we can measure, but always, nonetheless. And when we consider this, not just Atlas's path, but the starlight it altered, the trajectories it bent, the silent curvature it contributed, we understand something deeper. Every fragment has mass, every mass changes space, and in those tiny changes a story unfolds, not just of motion, but of vision. We see not just what is out there, but how it reveals what lies behind. As 3i Atlas curved away from the Sun, leaving the planetary orbits behind, it continued on its slow ascent toward the outer dark, where sunlight fades and stars begin to multiply. From this distance, Mars becomes just one quiet ember in a much larger fire, a warm dot against the black, circled by two pale moons and trailed by centuries of curiosity. And yet, it lingers in the mind. Because even as Atlas continues outward, past the invisible boundary of the heliosphere, Mars remains our closest link to a broader horizon, a stepping stone to everything beyond. It has always been that way. Before we had spacecraft, Mars was the farthest world we could see with detail. Its polar caps, its reddish tint, its shifting shadows, all stirred questions about other worlds, other climates, other histories. And today, though we've sent rovers, orbiters and landers, Mars still holds more questions than answers. When Atlas passed nearby, it wasn't just a fragment intersecting a planetary orbit. It was a reminder, subtle and fleeting, of the openness of space. Because even now, as Atlas moves outward, we know it is not alone. Beyond the edge of the solar system lie many more quiet places. There's the Kuiper Belt, where dwarf planets drift through dim light and forgotten orbits. There's the scattered disk even farther out, home to errant ice and strange, slow objects like Sedna. And then there's the Oort cloud. This vast, spherical halo of icy debris is only theoretical. No object has yet been seen in it directly. But models suggest it surrounds the solar system like a fragile shell, stretching a light year or more in every direction. It may be that Atlas passed through the outer edge of this cloud on its way in. It may pass through it again as it leaves. In this region, gravity is weak. The Sun is only barely a presence. Here, motion slows. Temperatures approach the cosmic background. Time feels longer, and yet even here, Mars casts its distant pull, not enough to affect objects directly, but enough to remain part of the map, a coordinate in the gravity field of the system, a landmark in the invisible terrain. We often think of the solar system as a flat disk, with planets orbiting in neat ellipses, but in truth, it's more textured. Beyond the inner planets lies a frontier not of emptiness, but of thresholds, places where orbits become stretched, where inclinations shift, where the sun's influence slowly releases its grip. These are the places where things pass in and out. And Atlas is one of those things. Its trajectory tells us it will not return. It is not captured. It will pass beyond, becoming once again part of the interstellar drift. But for a brief moment, it was here. It felt the pull of Mars. It bent slightly under its influence. It reflected sunlight into our telescopes, and then, like a seed on the wind, it continued. The farther it goes, the harder it will be to see. Eventually, even the most sensitive instruments will lose track of it, and yet we will remember. Because each of these interstellar visitors adds a thread to the quiet narrative of cosmic exchange. They are not just rocks. They are time travelers. They are fragments of systems we've never seen. And they teach us something not just about motion, but about openness. That the borders between stars are not walls, but bridges. That planetary systems are not sealed, but porous. And that Mars, dusty, old and still, sits at a kind of crossroad. Not the destination perhaps, but a witness. A waypoint for things that pass through, unnoticed but real. Atlas may never touch another world. It may drift until it erodes or collides, or fades into the quiet hum of background dust. But its journey changes us. It reminds us to look outward, to listen to faint signals, to imagine not just what we've mapped, but what still travels through the dark. And in doing so, it leaves behind something soft, not data, not debris, but a shape in the mind, a memory of motion, a whisper of deep time. Now we return once more to the red world beneath the velvet sky. Mars turned quietly, as it always has, carrying no knowledge of the object that passed so near. And yet, something about that fleeting closeness lingers in the imagination. What does Three-Eye Atlas want with Mars? Perhaps nothing, perhaps everything. We've watched its arc, brief, wide and elegant through the realm of planets. We've imagined its icy chemistry, its spectral fingerprints, its motion shaped by gravity and time. We've followed it through skies both Martian and earthbound. We've wondered at the chance alignment of moons, the hush of atmospheric resistance, the stirring of dust it never touched. And above all, we've asked, not what it did, but what it meant. Because meaning is not always about intention. In the realm of stars and comets, meaning often lies in resonance, in the way something strikes a chord with our own quiet search for belonging. Mars, in its stillness, reflects that search back at us. It is old, not in the way of years, but in the way of memory. A planet that remembers floods, frost, and the wind's long breath. A world with scars, with silence, and with patience. It's not hard to imagine Atlas drifting past and sensing, if only metaphorically, that this planet listens. It listens with frozen slopes and hollow craters. It listens with buried ice and the long shadows cast at dawn. And we, listening in turn, begin to recognize something else, that Atlas is not the first, that others have come, that even now the solar system may be hosting fragments we haven't yet seen, each one a quiet sentence from another place, each one a piece of an invisible script, written not in language, but in motion. We watch the skies now with more intent. We scan for dim arcs, slow drifts, odd redshifts, and when something faint appears, something fast and unfamiliar, we lean in, not to solve it necessarily, but to witness. Because to witness is to participate, and participation is all the universe ever really asks of us. To be here, to look up, to notice. So what does 3i Atlas want with Mars? Maybe it wants nothing. Maybe it simply passed by. Maybe it was caught in a long loop of gravitational nudges that brought it close before letting it go. But maybe, just maybe, it offered something else. A moment of nearness, a silent glimmer, a story for those of us paying quiet attention. Not every mystery needs a solution. Some are complete in their passing. And so we return to that imagined scene. Dust rising on a Martian plain, twilight glowing above, and a tiny icy traveller tracing its arc across a sky that has seen so much. The traveller won't return, the planet won't change, but something in us does. We remember, we imagine, we soften, because in that moment the cosmos felt a little closer, and Mars, a world that holds so many of our hopes, seemed to breathe with us just once. And now, as our journey drifts to its quiet end, we settle into the hush between stars. We've wandered with 3i Atlas, following its slow, poetic arc past Mars and into the deep. We've watched from imagined hills beneath a faded sky, traced the curves of gravity, and listened for meaning in the silence. We've stood in the thin dusk of a red world, eyes tilted toward the motion of ancient light. We've paused at the edge of dust storms, dreamed of buried ice, and followed the delicate pull of Lagrange points and starlight. What we found wasn't a message or an answer, it was a feeling that in the grand sweep of space, even the faintest fragment matters, even a whisper from the stars carries weight, and even a world as quiet as Mars has moments when something unknown draws near, pauses, and passes on. Tonight, you might imagine yourself on that planet, still, unmoving, watching a spark drift by overhead. It doesn't linger, but it leaves a trace, a softness, a silence, a shape in the dark that slowly fades. Now, let your breath slow, let your thoughts dim. You've travelled far without moving, you've listened without noise, you've learned without urgency. Out there, 3i Atlas continues its long journey, but here, under this quiet sky, you are home. Thank you for drifting with us tonight. Sweet dreams,